Okay, here's our Chapter 7 review. This was over polynomials. The first section for Lesson 7.1, you had to determine whether each expression is a monomial and write yes or no, and then explain. Number 1 is yes. Oops, and I need a pen. Number 1 was yes, it is a monomial because it is a constant, and we learned in that lesson that any constants are a monomial. Number 2 is not a monomial. You should notice that is a binomial, so that's not a monomial. It includes two monomials because we see a plus sign, so that makes it a no. Right here, that makes it a no. Number 3, this is a monomial, so this is yes because it's all multiplication. I don't see any addition or subtraction going on here. That sign in the front is a negative because it's not being subtracted from anything, and therefore number 3 is a yes. 4 is just a variable by itself, and that is a yes. Number 5 is a no because we are dividing by a variable, and you cannot have a variable in the denominator of a fraction for it to be a monomial. And 6 is a no also because we see some subtraction going on, and so that is 2 monomials or a binomial. Okay, for the next section, you had to, let's see if I can get the thing down, simplify. So when we multiply monomials being multiplied by each other, we add exponents because this exponent is telling us how many of that variable we are multiplying. And just to put the first one out, so that's y times y times y times y times y, that's the y squared, times y. So if I put it all out together, these are all being multiplied. That's what this is expanded. So 1, 2, 3, 4, 5, 6, well that's y to the 6th. But why would I have to do that when I could just add 3 plus 2 plus 1 here and I get y to the 6th? Okay, this is n to the 1st times n to the 8th. Don't forget, we always want to put our missing exponents. 1 plus 8 is 9. This one, number 9, again, I want to put my missing exponent, so that's a to the 1, so that's 3 a's being multiplied. And we haven't changed the rules for our coefficients. 2 times 8, those are not exponents, so it's still 2 times 8, so that is 16, so we get 16a cubed. Number 10, again, I'm going to take care of my exponents on my variables first. Then I'm going to figure out how many of those I have. So I have 3 a's being multiplied, so a to the 3rd. I have b to the 1st and b to the 3rd, so that's b to the 4th. So if I had expanded all those out, I would see 4 b's next to each other. And then 3 times negative 4 gives me negative 12. All right, number 11, now we have an exponent to an exponent. These are not being multiplied next to each other. I don't see another m here, m to the 7th. So this is saying take that m to the 6th and put it next to each other 7 times. Well, m to the 6th 7 times would be a total of 42. You know, that's 6 times 7, right? So we multiply when we don't see another exponent there. So that's m to the 42. Number 12, b has an exponent, so does c. So this 5 gets distributed to both of those exponents inside. So we get b to the 15th and c to the 20th. If you are forgetting your rules, again, write it out real quick. Do b to the 3rd times c to the 4th times b to the 3rd, c to the 4th, okay? And I do that 5 times all the way across, and then now I can add them, right? So 3 plus 3 plus 3 plus 3 plus 3, well, that's 15. And 4 plus 4 plus 4 plus 4 plus 4, that's 20. So that's how we get that. Remember, you always have a strategy. You can always expand it if you can't remember your rules. Here, I want to put my 1 next to my d, and I also need to put a 1 on my 5 because that also has an exponent. That 3 gets distributed to all the other exponents. So we get 5 to the 3rd, c to the 6th, and d to the 3rd. Sorry, it's a little messy. So we get 125. That's 5 to the 3rd. No, that's not. Yes, that is. 5 to the 3rd, c to the 6th, and d to the 3rd. That's your answer for that one. Number 14, I have a monomial raised to a power and another monomial raised to a power and then multiplied by each other. Notice again, there's no addition or subtraction going on here. I would have to say it in between these parentheses. Put in all of your missing exponents first. This 4 gets distributed to these 3 in here. This 3 gets distributed to these 2. So we get negative 2, and remember that it's negative 2 like that, to the 4th, f to the 8th, g to the 4th, and this is all being multiplied by negative 3 to the 3rd and f to the 6th. And remember, you have to keep that negative being raised to the power because that will tell me whether it's going to be negative or positive at the end. In fact, this one at the end is going to become positive 16, and then f to the 8th, g to the 4th. And this will become negative 27, f to the 6th. So we get this and this. And so we get f to the 14th, g to the 4th, and then we get 16 times 27, which I didn't have a calculator in front of me, and I'm not going to work that out real quick. So I guess I could. I'll go ahead and do it. So 16 times 27, so that's 2, 4, 1, 12, and then 12, 1, 3, so 432. 432, but one of them was negative, so it gives me negative 432. Okay, so that's what you should have gotten for that one. 15, same thing. Make sure you put your 1s on your coefficients because those are missing. The 2 gets distributed to each of those. The 3 gets distributed to each of these. And so we get 4 squared, r to the 6th, w to the 8th. And then I'm just going to put this all out to show you that it doesn't matter. I didn't have to put it in parentheses. This is 2 to the 3rd, r to the 6th, w to the 9th. Okay, so then these are all being multiplied. You can imagine little dots in between all these things. Okay, so 4 squared is 16, 2 to the 3rd is 8. So 16 times 8 is, I'll do this over here, 16 to the 8 is 128. So you should have gotten 128, r to the 12th, and w to the 17th. Okay, there's that. Oh, there's that last one. And you should have gotten all these answers in class as well. Okay, so now simplifies lesson 7-2. Assume that no denominator is equal to 0. So I have m to the 11th over m to the 4th. Just to remind you what is happening and why our rule works, you're looking at how many of these cancel, right? So this is 11 m's being multiplied all together. This is 4 m's on the bottom. Anytime we have m over m, that equals 1. So 4 m's are going to cross out of the top, right? So I have these 4 cross out, these 4 cross out. 4 of these cross out, so we're left with m to the 7. The way that the rule works is it's m to the 11 minus 4 because you're subtracting all the ones that will cancel out of that, and so that's why we get m to the 7th. So we're going to do the same thing with 17. So I get n to the 5 minus 1, p to the 4 minus 2, which equals n to the 4, p to the 2. Okay, and then for 18, we're going to do the same thing. And then when I get to the next one, I'll play the Who's Got More game for those of you that need that. So we get 18, a to the 4 minus 2, b to the negative 8 minus 5. Oops. See if I can get that. Negative 8. It's not coming up. So we get a to the 2nd and b to the negative 13. Well, remember, a negative means it's in the wrong place. So it needs to go to the denominator of a fraction, which obviously is not there right now. If I don't see a fraction, it's all in the numerator. So when I rewrite it, I get a squared over b to the 13th. The other way to think about this one is the Who's Got More game. Look at your a's. Who's got more, top or bottom? Top by 2. That gives us a squared. Who's got more, top or bottom? Bottom 5 by how many? By 13. So 5 is 13 more than negative 8. Okay, 19. Remember, do not do your rules on your coefficients. This is a fraction. It's negative 45 over negative 15, which equals 3. Okay, that's a positive 3. Now I look at who's got more, top or bottom of my a's. My top does by 6. Who's got more b's? Well, they're the same. If they're the same, b squared over b squared is 1, and they cancel, okay? Then I have my c's. Who's got more, top or bottom? The bottom does by 3, and then you're done. That's your answer. 20, same thing. 35 over 10 must reduce, okay? They're both divisible by 5, so I get 7 over 2. Then I just have to figure out where all my variables are, what party they need to go to. My x's. Who's got more, top or bottom? Bottom by 3, so that's x to the third. Then y's, who's got more, top or bottom? The bottom by 1, so that's a y. And then who's got more, top or bottom on the z's? The top by 3. Done. Okay, number 21. Before I can actually simplify this, I need to go ahead and distribute my exponent. But 2 is not the only one that has an exponent. Everything in here has an exponent. So it's 3 to the 1, b to the 1, 4 to the 1, d to the 1. So the first thing I'm going to do is distribute that 3 to everything. So I get 3 to the third, b to the third, c to the sixth, over 4 to the third, and d to the third. So that has now distributed everything, and I'm seeing if I can move or distribute, or not distribute, but cancel anything. The b, c, and d cannot cancel because they are not like terms. So I need to see whether this reduces or not. 3 to the third is 27. So I get 27. B to the third, c to the sixth, over 4 to the third, which is 16 times 4, which is 84. D to the third. And that will not reduce because, let's see here. Oh, it does reduce by 3. Is that right? M16. 3 goes into 18. So it reduces to, that's not right. Does 3 go into, goes into 2, 28. So we get 9 over 28. So these should have reduced to 9 over 28. You can check my math. Tell me tomorrow if I did that wrong, but I believe that's right. Okay, 22, same thing. We're going to distribute. So I get 2 times all of these. And then there's no distribution down here, so we get 3 squared, a to the sixth, b. Let me see, I kind of messed up there. Let me see what that is. It's b just by itself, okay? So b squared c to the fourth, all over 18 a squared b to the third c to the fourth. So that way, let's see here. I'm looking for things to cancel. Well, 3 squared is 9. I'm going to go ahead and do that. Change that. A to the sixth over a squared. This is going to become a to the fourth. B squared, b to the third, this is going to become b to the first. And then my c's are going to cancel. So I'm left with 9 over 18, which is 1/2. A to the fourth on top, and b on the bottom. This one, this is pretty easy. This entire thing, whatever it is raised to the 0, so that's just 1. Then this 2 gets multiplied to everything inside. So I get 20 squared. And y to the 20th? Well, 20 squared is 400, so that equals 1 over 400 y to the 20th. And the last one here, again, I'm multiplying, or I'm distributing the exponent to all the other exponents. So I get 4 a squared b to the sixth over 8, because that's 2 to the third. I'm sorry. See, I already did that wrong. That's 4 squared. And 2/3 will be 8, so that's already simplified. A to the 12th, b to the 6th. And so we get 16 over 8. I'm going to erase this part already. Let's see here. Erase this so I have more room. Okay, so we get 16 over 8, which is going to give me 2. And then who's got more a's, top or bottom? Bottom by 10. And the b's drop out, so it's just 2 over a to the 10th for number 24. Okay, so let's go down. Express each answer in scientific notation. Remember, for this one, you can plug it into your calculator, but my decimal is here right now, so I'm moving it to the left 1, 2, 3, 4, 5, 6, 7, 8. My number has to be between 1 and 10. So we get 8.76 times 10 to the 8th. It's as easy as that is. This is going to have a negative exponent because it's so small, and I'm moving it to the right. So 1, 2, 3, 4. I get 4.6 times 10 to the negative 4th because that shows that it's a small number. Evaluate, express each result in scientific and standard notation. Okay, so the first thing I'm going to do is 3 times 5.6. Oops, let's see here. And so we get 16.8. And then if you're doing your rule with your exponents, I get 10 to the negative 6 because I add my exponents with my like base. But we're not done because we can't have 16.8. We have to have 1.68. It has to be between 1 and 10. So 1.68 times 10 to the negative 5 now because we move the exponent to the left one, or we move the decimal to the left one. This one, if you plug it straight into your calculator, it will give you your answer. And so, or you can do 8.4 divided by 1.4. And we get 6. So let's see here. So we get 6 times, and then negative 6 minus a negative 9 is 10 to the 3rd. Okay, and you're done, because that is between 1 and 10. Okay, back page. You're finding each sum or difference. Remember, if there is a plus sign in between my trinomials, binomials, monomials, whatever it is, they're being added. We are not multiplying, so you're just looking for like terms. So these are like terms. My MN is a like term. Let me put a lines under that. And then I've got 3 lines under my numbers, right? My constants. So I have 11 plus 5 m squared n squared, so that's 16 of those. So 16 m squared n squareds. I've got 4mn plus 6mn, so that's 10mn. And then negative 6 plus 17 is plus 11. Okay, same thing here. So 7c squareds. And here I'm subtracting. So what we're going to do is actually go ahead and distribute that through and rewrite it. So I'm going to get 7c squared plus 4. That doesn't change because nothing is impacting that. That stays the same. Then it's minus 3c squareds minus 2c's, right? And then negative minus a negative 6, so that's plus 6. So now I look at my 7c squareds and I've got negative 3c squareds. I've got 4 here, I've got 6 here, and then this one just doesn't have anything to add to it, so it's by itself. So our answer is 7c squared minus 3c squared, which is 4c squared, minus 2c, plus 10. Okay, then here we're adding again, so I don't even have to distribute. I'm just looking straight at my like terms. I get 7x squareds. I get 3x minus 4x, which is negative x. And then this is a standalone constant, so minus 3. Here I'm going to distribute through again, and we're going to rewrite. So I'm going to get negative 7a squareds plus 7a and minus 5. So now I've rewritten those. I don't have to put them in parentheses anymore because that's already been distributed. So 5a squared and negative 7a squared. Then I've got 6a and 7a and 2 and negative 5. So let's add our like terms, and we get negative 2a squared plus 13a minus 3. Okay. Now we go on to multiplying a monomial times a binomial and then simplifying. So I distribute this b through, so we get 4b squareds, because that's b times 4 times b, so 2 b's are being multiplied, and then b times negative 1, so it's just minus b plus 10b, and that negative b plus 10b will turn into, when I simplify it, so I get 4b squared plus 9b. Okay. Then 34, you're distributing twice here, but then you're still going to just add like terms. So I get 3x squared minus 5x plus 7x squared. And you can be writing this out to where 7 times x squared, 7 times negative 2x, 7 times 9. Because if you don't see what I'm doing here, I would be writing it out like this, like x times 3x plus x times negative 5. Do you see how I'm just showing? And then figure out which each binomial is if you can't do this yet. So 7x squared, 7 times negative 2x, which is negative 14x, and 7 times 9, which is 63. Then this last one, it's just a little more involved because we are dealing with bigger exponents on my variables. So now it's not only 8y, but it's 88y to the third, so 3, then minus 16y squared, then plus, what is that, 104y. Then this will be negative 27y cubed plus 63y, and then minus 18. Okay, so I've got y cubed here, and I've got y cubed here. So 88 minus 27 is 61. So we should have gotten 61y cubed. And then here are y squareds. I only see a y squared right here. So it's just minus 16y squared. Put 2 lines under that. Then our y, so 1, 2, 3 lines, 1, 2, 3. So 104 plus 63 is 167. And then minus 18, because that's the only one that's there, so minus 18. So that's section 7.6. So now we need to find the products of 36 through 43, and I'm actually going to put them in the next video by themselves just so I have more room to work on them. So look for the next video if that's what you were waiting for. And then this one, you had to find the area, unless otherwise specified, I believe, on the area of each figure. So remember, area equals 1/2 base times height for a triangle. So I'm going to do 2x minus 2, excuse me, times, and that's a minus, 4x plus 2. That x is really wonky. 4x plus 2. And then I'm going to take a half at the end, but it's a half of that. So I'm going to do the FOIL method for us for right now. So I get 2x times 4x gives me 8x squared. Then 2x times 2 gives me 4x. Then negative 2 times 4x gives me negative 8x. And negative 2 times 2 gives me negative 4. Now remember, you could have done this the box method or the vertical method, any of those. They'll all get you the same answer. So again, there's still a half in front of here. We don't want to forget about that. So I'm going to combine like terms. I get 8x squared minus 4x minus 4. And so then I get 1/2 here. So I'm going to take half of all of these. These are all nice even numbers, so that's easy enough. I get 4x squared minus 2x minus 2. This one, to find the area of a rectangle, is area equals base times height. So x squared times x to the 5th is just x to the 7th. And we're done. Okay. The last one down here, it's kind of hard to see. Let's see if I can get down there. You're actually, the measures of two sides of the triangle are given. If the total perimeter is 10x plus 5y, find the measure of the third side. So I'm just going to take the total and subtract these off. So I'm going to get 10x plus 5y. So that's that amount minus 3x plus 4y, and plus 5x minus y. So that whole amount, all I did was add those two together. I just combined them. So that's all together right there. So I get 10x plus 5y, And I'm going to go ahead and simplify this in here before I distribute. So I get 8x plus 3y. So now I'm going to distribute that negative through. So I get negative 8x minus 3y. That's going to be the biggest problem, is that you forget. You remember the first one, but you forget the second one. It's a negative 1 in front here, so that's got to be distributed like any other number. And then I get 10x plus 5y. And so 10x minus 8x is 2x, and 5y's minus 3y's is minus 2y, or plus 2y, excuse me. So I got positive 5 minus 3. So that's your answer right there. That's the third side. Okay, the volume of a figure of a cube like this is each side cubed. So I could do this, 3h squared cubed. Well, this gets distributed to all the exponents. Remember, there's a 1 here. That's not 3 times 3. That's 3 to the third, which you'll get 27h to the sixth. Okay, so to get the other problems, let me go back up here if I can. For numbers 36 through 41, look at the next video.